Okay, so question 1 is asking for the percent composition of C5H10O5, which is a molecule that is given to us. So you're going to find the molar mass of this molecule. So carbon has 12.01 grams, and because there's 5 elements of the same of carbon, you multiply that by 5. So hydrogen has 1.00 grams, and because it has 10, so you multiply that by 10. Oxygen has 15.99 grams, and because it has 5, you multiply that by 5. So this equals to, carbon equals to 60.05, and then hydrogen equals to 10, and oxygen equals to 79.95. And the molar mass of this is 150 grams of C5H10O5. So now to find the percent composition, you're going to get the molar mass of the element divided by the molar mass of the molecule times 100. So for carbon, it's going to be 60.05 over 150 grams of C5H10O5 times 100, and that's going to give you 40%. For hydrogen, you're going to do 10 grams of hydrogen over 150 grams of C5H10O5 times 100. And that's going to give you 6.66%. And for oxygen, you're going to do 79.95 over 150 grams of C5H10O5 times 100, and that's going to equal to 53.3%. And this is how you find the percent composition. For question 2, it's asking to find how many moles in this equation. So they're given, in the question they're giving you that you have 34.6 grams of C5H10O5, and you want to find how many moles of it that you have. So from previous question 1, you know that you have 100 grams of C5H10O5 as a total mass, and what you're going to do is just have do your dimensional analysis. So you know you're given, and then you're going to put your total mass of the whole molecule on the bottom. So 150 grams of C5H10O5, and then you notice that this cancels out, and then you're trying to find the moles. So when you divide 34.6 by 150, you're going to get 0.23 moles of C5H10O5. So for question number 3, it's asking you to find the empirical formula of this molecule. You're gonna, since you're not given like any percentages or something to convert to like grams, you can just easily know that you find the common denominator of the numbers here, and that's going to be 5. So you're just going to divide everything by 5. So 5 divided by 5 is 1, so it's C. Then 10 divided by 5 is 2, so H2. And then 5 divided by 5 is 1, so O1. And that's going to be your empirical formula. But you can also do it another way, where you can get the molar mass of this element. So for carbon, it's going to be 60.05 grams of carbon, and then the mass of just one single carbon is 12.01. You're trying to find 1 mole. So that's going to equal to 5 when you divide 60 by 12. And then, so this is carbon. And then for hydrogen, you're going to get the given molar mass of it. So it's 10 grams of hydrogen. And then the mass of just one hydrogen is 1 gram of hydrogen over 1. So when you divide this by this, it equals to 10. And then for oxygen, it's 79.95 grams. And then the mass of just one oxygen is 15.99 grams of oxygen. And then when you divide this by this, it's 5. So you're just going to divide by the lowest number. And the lowest number is obviously 5, so you just divide by 5 on each of the answers. And this equals to 1, this equals to 1, and this equals to 2. So when you come back, it's going to be CH2O. And it's just the same thing as this over here.
Okay, so for our molecule, we are told to draw it, and so to first start out with our drawing, we have to figure out how many electrons we're supposed to draw. So you look back at your periodic table, and so for carbon, it is given 4 valence electrons, but we have 5, so you're going to multiply it by 5. And then hydrogen just has 1, so you multiply that by 10. And then oxygen is given 6, and we have 5. And so you add these all together, and when you add them together, you get 60 electrons. So then you have to decide what your central atom's going to be, and we picked carbon because it is the furthest left. So we draw out our 5 carbon, and then we connect our oxygen. And then you can also connect each of these together. And then off of both of these, we're going to connect the rest of our hydrogens. And after we do this, all of our hydrogens will have they're satisfied because then we have to have 2. And so we can go and fill our outside carbons because they do not have all 8. So we just draw 2 lone pair of electrons on the outside 2. And then our oxygens need 2 lone pairs as well on either side. And then when you count all this up, it equals 60 electrons. So you're done with your drawing. And then we're asked what the geometry of our carbons are. And so these middle 3 are AX4, and therefore they are tetrahedral. And then our outside 2 are AX3, just 1, and so they're trigonal pyramids. So again, not all of our carbons have the same geometry. The outside 2 are different than the middle 3.
Go.
Okay, so for question number 5, we're asked to balance the equation of our molecule combined with oxygen, and we know when something reacts with oxygen that it is a combustion reaction, and so our products are carbon dioxide and water. So we have each thing labeled A, B, C, D. Yeah. And so for carbon, we have 5A equals C. And then for hydrogen, we have 10A equals 2D. And for oxygen, we have 5A plus 2B equals 2C plus D. And so we can write out our letters. And we can just assume that A equals 1. So if 5 times 1 equals C, then we know that C is 5. And when we go to our next one, we have 10, crap, hang on. Yeah, that's right. Go to this one? Oh yeah, okay, just kidding. So 10 times 1 equals 10, and then divided by 2, you know that D is also 5. And then you can plug these into your last one. So you have 5 plus 2B, which is what you're looking for, equals 10, because we have 5 is C plus 5. So then we can subtract this 5, and this 5 will cancel out. So we have 2B equals 10, so B equals 5. And when you write it out, your balanced one, you have C5, H10, O5 plus 5, O2 yields 5 carbon dioxide plus 5 water. Just whenever you tell me.
Go.
Okay, so for number 6, we're asked if we have 34.6 grams of our molecule, which is C5H10O5, and we have that with 19.6 grams of oxygen. How much carbon dioxide and water will we generate? And so, like Jocelyn went through in question 2, we had to find the moles of our molecule and oxygen. So going back through what she did in question 2, we find out that 34.6 grams is equal to 0.23 moles of C5H10O5. And then for oxygen, we know that O2 has a molecular mass of 32 grams. So we find that it is equal to 0.6125 moles. So then we use our ratio from our balanced equation, and we know that 1 mole of C5H10O5, the ratio is 1 to 5. So then we can use that to find out how many moles of oxygen we're gonna need when we're given 34.6 grams. So when you do the math, you end up with, you need 1.15 moles of oxygen, but we're only given 0.6125 moles, so that we can figure out from that for question number 7 that oxygen is our limiting reactant. And then from this, we can go back to our balanced equation, and we have for every 5 oxygens, we need 5 carbon dioxide and 5 water. So our ratio there is 5 to 5 to 5, or 1 to 1 to 1. And so then we can just assume then that we're going to generate the same amount of moles of carbon dioxide and water as we are given of oxygen.
Okay, so for number 8, it asks us how many sigma and pi bonds our molecule has. So going back to what Lizzie drew earlier, this is our Lewis structure for C5H10O5. And so sigma bonds are, this is an example, it's the first bond between 2 elements. And pi bonds, in this example, this would have 1 sigma bond, and then the second bond would be considered a pi bond. So if you add all these up, we have 19 sigma bonds, and we don't have any pi bonds. Number 9 is asking us if we have any polar bonds. So first we have some general rules about polarity, and we got these by looking at our electronegativity chart, and whatever is bonded, you subtract the 2. And so our electronegativities for carbon, we have 2.5, and then hydrogen is 2.1, oxygen is 3.5. So for bonds between carbon and hydrogen, you subtract the 2, and so we end up with 0.4. So looking back to these, that means that bond is nonpolar. And then looking at the bonds between carbon and oxygen, the difference is 1, so that one would be polar. And then oxygen and hydrogen is equal to 1.4, so that one is polar as well. But none of these are polar enough to be considered ionic.
Go.
So question 10 is asking us what is the hybridization for the carbons in this molecule. And so what you're going to do is you'll look at the structure of carbon, just one carbon by itself, and you see that it has 4 adjacent bonds. And so you're going to come over to our rule of hybridization and you count 4, so it'd be S, P, P, P. And so our hybridization for one carbon is going to be sp3. And then you would come back and do that again for the second carbon, and you'll see that they all have 4 around each of them, so they're all the exact same, and it's sp.